Hi all, very happy morning, happy afternoon, happy evening to every viewer who is watching this video at appropriate point of time. Very interesting class, very exciting class. There is a reason behind taking this class. Yesterday when I was having dinner with some of my junior faculties who worked with me in Career Launcher, they just showed a random video related to the approximate value of a non-perfect square. So then I asked, do you know the proof behind this concept? Why this concept came into picture? And my friend of mine said, no. I copied this from another YouTube video. I just kept it to get some views. In case if you are a student who want to know the why behind a particular concept, in case if you are a student who wants to learn the gold standard content, who wants to learn from the author of 9 mathematical books, this class is a must attend for you. At the end of the class, you are going to learn a lot of concepts related to how to find the approximate value. How to find the approximate value. How to find the approximate value for square root of 29, square root of 5829, cubed root of 13, cubed root of 121, fifth root of 7292624. How to find out the approximate values for a non-perfect squares, non-perfect cubes, and non-perfect fifth powers with complete proof behind the concept. At the end of the class, you will be able to explain the reason behind why that concept is used. Why that concept is used. Probably for the first time, if you check these logics in anywhere in YouTube channel all over the world, you might not get the proof behind the concept. Now we are going to discuss the proof behind the concept, because if I firmly believe in explaining the why behind the concept rather than just solving a mindless problem solving. Very interesting class, very exciting class. In case if you enjoy this concept, kindly like and subscribe to RYP channel and Anil Nair classes channel, and share this class with every teacher who has given this video without giving you the proof behind that video. I firmly believe that generally many of them teachers students to remember the formulae. I teach the logic behind the formulae. Many of them tells you to cram the information. My classes are to acquire the knowledge. They tell everything which probably results in a short-term memory. I emphasize on understanding the concept and appreciating the concept. Many of them says that textbooks are the end points. I say that from the textbook you can take the concept to the next level. How to find the approximate value of a cubed root of 1337. How to find out the cubed root of a 13724. And how the cubed root is determined. How to check whether a number is a perfect cube or a non-perfect cube. How to check whether a number is a fifth power or a non-fifth power. Let us straight away get into the concept. Very interesting concept. Very exciting concept. Let us see the concept first. Concept. Key point number 1. One by one we will discuss the key points. Key point number 1. A perfect square. A perfect squares always will be of the form. 4 into something or 4 into something plus 1. Any perfect square will always be of the form 4 into something or 4 into something plus 1. Why? We have already discussed in our perfect squares class. A perfect square will always be of the form 4k or 4k plus 1. Second concept. A perfect square never ends with. A perfect square never ends with 2, 3, 7 or 8. This is the second property of a perfect square. These also we discussed. Third property. What is the third property? Every perfect square, digital sum will be 1, 4, 7 or 9. Every perfect square, digital sum will be 1, 4, 7 or 9. 1, 4, 7 or 9. For a number to check whether a number is a perfect square or not, first check whether it is of the form 4k or 4k plus 1. A perfect square never ends with 2, 3, 7 or 8. Every perfect square digital sum will be 1, 4, 7 or 9. For example, root of 29 it is there. Root of 29. Root of 29. 9 plus 2, 11. 11 is 1 plus 1, 2. Every perfect square digital sum should be 1, 4, 7 or 9. 1, 4, 7 or 9. So it is a non-perfect square. This is a non-perfect square. Then non-perfect square. Non-perfect square. Suppose if it is 154, it is there. 154. Square root of 154. A perfect square will always be of the form 4k or 4k plus 1. 54. 4 into 13, 52 plus 2. A perfect square will never be of the form 4k plus 2 or 4k plus 3. Again, it is a non-perfect square. Again, it is a non-perfect square. A non-perfect square. A non-perfect squares always gives an approximate values. A non-perfect squares always gives an approximate values. How to find the approximate value of a non-perfect square? Square root of 29. 2 plus 9 is 11. 1 plus 1, it is 2. If the number is a perfect square, it should have digital sum 1, 4, 7 or 9. This digital sum is 2. This digital sum is 1, but it is not of the form 4k or 4k plus 1. These are the three tests that we need to conduct to check whether a number is a perfect square or not. I hope it is clear. First point, write down in your notebook. First point, write down in your notebook. First point. These are some important key points. At the end of the class, you will not get a single doubt. That means if root n it is there, n is a perfect square. N it is a perfect square. N it is a perfect square. I will get an integer. I will get an integer, positive integer, which is nothing but a natural number. Square root of positive number is always a natural number. If n is a non-perfect square, if n is a non-perfect square, if n is a non-perfect square, I will get a decimal value, and which is an approximated value. Approximated decimal value. Approximated value. If n is a non-perfect square, I will get an approximate value. If n is a perfect square, I will get a positive integer, or it is a natural number. This is something which you will find it in all the textbook. Now we will see how to find out the approximate value of a non-perfect square. How to find the approximate value of a non-perfect square. Very interesting logic. Watch till the end of the class. Then you will understand the beauty of thematic based learning. You will understand the beauty of thematic based learning. Approximate value. Approximate value of a non-perfect square. Approximate value of a non-perfect square. Approximate value of a non-perfect squares. I will teach you multiple methods. Approximate value of a non-perfect squares. First one, square root of 29. Square root of 29. Multiple methods with the proofs. Method 1. This is not anybody's method. This is proposed by a famous mathematician by name Trachtenberg. Trachtenberg. Trachtenberg's method. Trachtenberg's method. Square root of 21. How to find out the approximate value of a non-perfect square. A non-perfect square will never give an natural number at the end. How to check whether a number is a perfect square or not? All that we discussed. Trachtenberg says square root of 29. Root of 29 lies between which two squares? One is the square root of 25, another is square root of 36. Square root of 25 and square root of 36. Root of 25, it is 5 plus. 29, 25, difference is 4. 36, 25, difference is 11. So answer is 5, 4 by 11 approximately. 5, 4 by 11 approximately. From where this concept came, limit h tends to 0, f of x plus h minus f of x by h. From these limits, he has given these proof. You can actually download Trachtenberg's book of speed mathematics, then you will get this approach. What he did, square root of 29 lies between which two squares? Root of 25 and root of 36. 5 plus 4 by 11. 4 by 11 is approximately 0.36, so it is 11 3s are 33, 70. Close to 5.36. This one method. I am not interested in a foreigner's way of solving. Ramanujam has proposed another interesting way to solve a problem that we will see. One more example. Square root of 137. Square root of 137. A perfect square never ends with 2, 3, 7 or 8. A perfect square never ends with 2, 3, 7 or 8. It lies between 11 square is 121, 12 square is 144. 11 plus 137, 121, 16. 144, 121, 23. Approximately it is 11, 16 by 23. Approximately it is 11, 16 by 23. I hope the concept it is clear. I hope the audio it is clear. Let me check it out. Just give me 2 seconds. Is the audio clear? Right. I think the audio it is clear. This is Trachtenberg's way of finding the approximate value of a non-perfect square. The source for this book is Trachtenberg Book of Speed Calculation. Trachtenberg Book of Speed Calculations. Trachtenberg Book of Speed Calculations. You will easily get these PDF in Google from that concept which we are discussing. I am not interested in this method. I will tell you another alternative method proposed by a famous mathematician coming from India. That is my inspiration, Ramanujam's. Method number 2, we will discuss Ramanujam's method of finding the approximate value of a non-perfect square. It is good to know this method. Square root of 29 lies between which two perfect squares? Root 25 and root 36. Root 29 is anyway greater than root 25. 5 plus 29, 25. Difference is 4. 36, 25. Difference is 11. So answer is approximately 5, 4 by 11. This is nothing but 11, 16 by 23. I hope this method is clear, but my entire attention is on Ramanujam's method. Ramanujam's method, everyone should know this method, and he is one of the prodigy in the field of mathematics. Ramanujam's method. Method number 2. Very, very important method. That is what I was telling my friend. Unless you know the proof, how come you are teaching a concept? Are the students not asking you the reason behind why it is happening? Ramanujam's method. Now Ramanujam's method is square root of 29. Square root of 29. Root of 29. It is just greater than nearest perfect square. Root 25, it is 5. Root 25, it is 5. 5 plus 29, 25. What is the difference? 4. Double this value. 10. So both are approximated values. Trachtenberg method has given us 5, 4 by 11 Ramanujam's method will give you 5 4 by 10. Don't do this mistake of, this is what I used to do it in school days. 5 ones are 5 twos are 2 ones are 2 twos are. That is a stupid way of understanding mathematics. It will happen if you got a bad teachers in your life. I hope it is clear. Don't do all this. 5 4 by 10. 5 4 by 10, it is nothing but 5 4 by 10. 5 4 by 10 is 5 2 by 5. It is approximately 5.4. 5.4. 54 whole square is 2916. 5.4 whole square is 29.16. 29.1 is very, very close to 29. So square root of 29, this is the value. I said, did you discuss it the students how these 4 by 10 you got? You are telling it vaguely. 29 minus 25, it is 4, and double this value. This is where some smart students will ask you a doubt, and smart students knows that you are just telling it from a textbook without giving you the proof. If you see any kind of YouTube videos where they are teaching you like this without giving you the proof, you can understand the level of subject knowledge they got it. One more example, square root of 43. Square root of 43. You can do this one either by taking a perfect square just less than 43 or a perfect square greater than 43. Root 36, it is 6. 6 plus 43, 36, it is 7. Double this value. So it is closer to 6 7 by 12. It is closer to 6 7 by 12. Hey Anil sir, can I take root 49, which is nothing but 7? Root 43 is less than root 49, so minus. Difference is 6. So this is nothing but 7 minus 3 by 7. 46 by 7. 6 6 are 7 6 are 42. 6 4 by 7. 6 4 by 7. So 6.5 whole square is 42.25. Either you can take a perfect square just less than root 43, or you can take a perfect square just greater than root 43. I hope this method is clear. The entire class is developing an approach which makes you to solve the questions for a non-perfect square, non-perfect cube, and so on. I am not interested in telling this model. I am interested in teaching a concept which will help you to solve any powers beyond non-perfect squares. Here, why I discussed this? Sir, can I take a perfect square less than root 43? Yes. Root 36, it is 6. 43, 36, it is 7. Double this number. Root 43 is less than root 49, 7 minus. 43 is less than 49, so minus. Difference is 6. Double this number. Why are we doubling this number? Why are we taking a difference? The entire class is about telling you from where you got this point. From where you got this point. Now, listen carefully to the next explanation. Anil Nair's proof. Why that came into picture? Why that came into picture? Very, very interesting and an exciting way of looking at aptitude through a prism never seen before. Anil Nair's proof. Now listen carefully. Suppose root A, I need to find out root A. What is A here? A is nothing but a non-perfect square. A is nothing but a non-perfect square. A is nothing but a non-perfect square. I want to find out the approximate value of a non-perfect square. Listen carefully, sir. For example, A is 29, A is 31, A is 54, A is, for example, 235. All these are perfect squares. All these are perfect squares. Can I say root 29 is greater than root 25? Am I right? Or it is equivalent to, or it is greater than root 25. Can I write? Root 31, it is greater than root 25, yes or no? Root 54, it is greater than root 49. Are you all with me? Root of 235, it is greater than root of 225. Are you all with me? Am I right? Now listen carefully to this concept. Can I say 29 is nothing but 25 plus something? Yes or no? 31 is nothing but 25 plus something. 54 is 49 plus something. 235 is 225 plus something. 225 plus something. Let these A is nothing but I plus E whole square. I plus E whole square. What is I plus E? I is nothing but a nearest integer. E is nothing but an estimated approximation. E is nothing but an estimated approximation. E is nothing but an estimated approximation. Like a previous example, 29 is 25 plus something. That something value we are trying to find out. 31 is 25 plus something. Something value we are finding it out. Root 29 is greater than root 25. Answer will be 5 point something. What is that something we are trying to find out? Root of 103 is greater than root 100. It is answer is 10 point something. What is that something we are trying to find out? What is E here? E is nothing but an estimated approximation. E is nothing but an estimated approximation. So A is nothing but I square plus 2 into I into E plus E square is E square. A plus B whole square is A square plus 2AB plus B square. I hope the concept is clear. I square plus 2 into I into E. I is the nearest integer. I is the nearest integer. I is the nearest integer. Now, see here. A is 29. I is 5. 5 square plus something. That means, can I say estimated value is a very smaller value? Do you agree? Estimated approximation value. It is nothing but a smaller value. Anyway, it cannot be 1. 5 plus 1 is 6. 6 square is 36. E is very, very small. E is very, very small than I. E is nothing but dot something. Root 103 is 10 point something. That something after dot, it is nothing but E. Root of 154 is 12 point something. What is that something after dot we are finding? It is a very smaller value. It is a very negligibly smaller value. A minus I square equivalent to 2 into I into I. E. Approximated to, because it's a very smaller value, point something whole square. This value addition, it will make a very, very nominal difference. That means E is nothing but A minus I square divided by 2 into I. A minus I square divided by 2 into I. I hope the concept is clear. E is nothing but an estimated value, which is a very smaller value. I square plus 2 into I into E plus E square. It's a very smaller value. Anyway, I am finding the approximate value. So I can eliminate E square. I can eliminate E square because E square is a very smaller value. A minus I square is 2 into I into E. E is nothing but, again I am writing, A is nothing but I plus E whole square. Once you understand, you can also teach the teachers. I square plus 2 into I into E plus E square. E is an estimated approximated value. E is an estimated approximated change. E is an estimated approximated change. So this is a very smaller value. So A will be extremely close to I square plus 2 into I into E. I square plus 2 into I into E. So this I is nothing, E is nothing but A minus I square divided by 2 into I. Now the concept will be extremely clear to you. Now the concept will be extremely clear to you. Now I want to find out root of A. That means it is root of I plus E whole square. Square under root cancel. It is nothing but I plus E. E is nothing but A minus I square divided by 2 into I. Finish. It is nothing but root A approximate value. It is nothing but I plus A minus I square divided by 2 into A. I hope the idea it is clear. This is how the aptitude is developed. Just nothing but the mugging up concepts, taking an R.S. Agarwal book and solving 20 problems, creating a PPT and taking the class is not a measure of an efficient teacher. A teacher knows how the concept is derived and where all it can be used and where all it cannot be used. Where all it cannot be used. Suppose root 29 it is there. Now it is clear. I is the nearest integer. I is the nearest integer. What is the nearest integer? Nearest integer is 5. Because square root of 25 it is 5. I hope the idea it is clear. A minus I square. A is 29 minus I square divided by 2 into 5. So 5 plus 4 by 10. That is how the concept is derived. I hope this concept is extremely clear to you. How to find the approximate value of a non-perfect square with a proof. A is nothing but I plus E whole square. I is the nearest integer. A is the estimated approximate change. Square root of 31 is 5 point something. That something is nothing but A. A is a very smaller value. Because I require approximation, A is approximated to I square plus 2 into I into E. E is nothing but A minus I square by 2 into I. I hope the idea it is clear. I hope the idea it is clear. Now we will solve multiple problems. So what is the concept? Approximated value. Approximated value of a non-perfect square. Approximated value of a non-perfect square. If A is a non-perfect square, if A is a non-perfect square, A is a non-perfect square, I want root of A. I want root of A. If I want root of A, what will be the answer? Answer is nothing but I plus A minus I square divided by 2 into I. A plus I square divided by 2 into I. I is the nearest integer. Nearest integer just less than root of A. I is the nearest integer just less than root into A. I hope the concept is clear. For example, root of 43 it is there. Root of 43. What is the nearest integer just less than root A? Root 36 is less than root 43. Root 36 it is nothing but 6 plus 43 minus 6 square divided by 2 into 6, which is 6 plus 7 by 12. Approximately answer is 6, 7 by 12. Not a single video in YouTube channel all over the world you will get these proof. Second one, for example, root of 71. 71. What is the nearest integer just less than root 71? Root 64. 8 plus 71 minus 8 square divided by 2 into 8. I want my students to be different from others. When they are explaining my logics to their friends who has not seen any of my videos, they should say it with 100% conviction. Answer is 8, 7 by 16. Answer is 8, 7 by 16. How to find the approximate value of a non-perfect square? You can proceed it to a 3-digit number or a 4-digit number or a 5-digit number. Let me take For example, 7754 it is there. 7754. It is not a perfect square because any perfect square is of the form 4k or 4k plus 1. It is 4 into 13 plus 2. 88 square is just less than 7754. 88 plus 7754. 88 square is 7744 divided by 2 into 7744. This will give you the 88 dot approximated value. I hope the class is concept is clear. How to find the approximate value of a non-perfect square? 2-digit number, 3-digit number, 4-digit number, and so on. Any digit number you can solve. I hope the idea it is clear. Next one, how to find the approximate value? How to find the approximate value of a non-perfect cube. Then slowly after 5 to 10 minutes, you will be able to solve any non-perfect nth powers. How to find the approximate value of a non-perfect square we already did. Let us do non-perfect cube. How to find the approximate value of a non-perfect cube? First some key points. Key points. First see here. Perfect cube key points. Perfect cube key points. Then we will see when the numbers will not be perfect cubes. Perfect cube key points. Now listen carefully, sir. After 5 to 10 minutes, this concept will be very clear to you. What do you mean by digital sum? Digital sum is defined as the sum of the digits until a single digit is obtained. Digital sum is defined as sum of the digits until a single digit is defined. 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the possible digital sums of every number. What is a very important key point with respect to perfect cube? Now see here. 91 if I take, what is the sum of the digits? 9 plus 1, 10. 10 is nothing but 1. 181 digital sum is 1. 9991 digital sum is 1. I am taking the set of all the numbers whose digital sum is 1. I am taking the set of all the numbers whose digital sum is 2. I am taking the set of all the numbers whose digital sum is 3. If I cube it, I will get a perfect cube. 1 cube it is 1. 2 cube it is 8. 3 cube it is 27. Digital sum is 9. 4 cube 64. Digital sum is 1. 5 cube 125. Digital sum is 8. 6 cube 216. Digital sum is 9. 7 cube 343. Digital sum is 1. 8 cube 512. Digital sum is 8. 9 cube 729. Digital sum is 9. Very, very important key point. If the number is a perfect cube, then the digital sum of that number will always be 1, 8 or 9. 1, 8 or 9. We will write down that point. Every perfect cube has a digital sum. Every perfect cube has a digital sum. 1, 8 or 9. 1, 8 or 9. Reverse may or may not be true. If a number is a perfect cube, then the digital sum of that number will always be 1, 8 or 9. Very, very important concept, so that you will understand how, when the approximate value of a non-perfect cube you have to find, and when the direct answer you will get. If a number is a perfect cube, then the digital sum will always be 1, 8 or 9. 1, 8 or 9. If the number is a perfect cube, then the digital sum will always be 1, 8 or 9. Reverse case may or may not be true. If a number is a perfect cube, digital sum will always be 1, 8 or 9. We will write down that point. If the number is a perfect cube, if the number is a perfect cube, then digital sum will always be, 1, 8 or 9. Very, very important key point. Very, very important key point. For example, cubed root of 13. Cubed root of 13. What is the digital sum of 13? Digital sum of 13, it is 4. If the number is a perfect cube, it should have digital sum 1, 8 or 9. So 13 is a non-perfect cube. 13 is a non-perfect cube. 13 is a non-perfect cube. For example, cubed root of 65, it is there. What is the digital sum of 65? 6 plus 5, 11. 11 digital sum is nothing but 2. So 65, it is a non-perfect cube. Non-perfect cube. How to find out the value for a perfect cube? That is something which is very easy. You will get it in tons of videos. In case if you are watching my video, every class of mine, I will try to teach something new and innovative for you, so that it will also be a great learning happiness for you. So first write down cubed root of n. Cubed root of n. If n is a perfect cube, if n is a perfect cube, output will be a natural number. Output will be a natural number. If n is a non-perfect cube, if n is a non-perfect cube, this value will be an approximated decimal. Same like what we did for a non-perfect square, same approach I will solve, so that you will understand how you will get the answer. If n is a perfect cube, then the output will be a natural number. If the n is a non-perfect cube, then I will get an approximated decimal. Then I will get an approximated decimal. Then I will get an approximated decimal. Very, very important slide. If the number is a perfect cube, the digital sum of that number will always be 1, 8 or 9. Wherever the digital sum is not 1, 8 or 9, how to find out the approximate value of a non-perfect cube? How to find the approximate value of a non-perfect cube? I hope this concept is clear. Same. Now, another beautiful concept. Same thing what we did. Watch the entire video. Then you can find out approximate value of a non-perfect nth power also. Non-perfect cube. How to find the approximate value of a non-perfect cube? Now see here. How to find the approximate value of a non-perfect cube? Cubed root of a, it is there. A is a non-perfect cube. A is a non-perfect cube. Non-perfect cube will have digital sum values anything other than 189. Anything other than 189. For example, cubed root of 13, it is there. It is greater than cubed root of 8. It is greater than cubed root of 8. Cubed root of 125, it is there. It is greater than cubed root of 64. It is 126 we will take. It is greater than 125. 126. 126. 126. 125 is 5 cube. 126. This proves a point. Any number, if the digital sum is 1, 8 or 9, then the number may or may not be a perfect cube. So 126 is greater than. Same, if it is square, what I did square. I plus e whole cube. I plus e whole cube. What is I? I is the nearest integer. I is the nearest integer. Just less than cubed root of a. I is the nearest integer, just less than cubed root of a. E is the estimated value. Estimated value. E is what we need to find out. E is the estimated value. Now see here. Now see. A is I plus e whole cube. A plus b whole cube. One is a cube. Next is 3a square b. Next is 3ab square, and next is b cube. Next is b cube. Now see here. Now listen carefully. These are nothing but estimated value. It is very small. Cube the root of 10 is 2 point something. These are all very small values. So I can approximate by taking first two values, I cube plus 3i square into e. So e is nothing but a minus I cube divided by 3 into I square. I hope the concept it is clear. E is nothing but a minus I cube divided by 3 into I square. Same thing I did. If it is a non-perfect square, I did I plus e whole square. If it is a perfect cube, I did a plus e power 3. A plus e power 3. So we will write down here. Then you will be able to understand everything. A is I plus e whole square. So these are nothing but a is approximated to a square plus 2 into I into e. E is nothing but a minus e square divided by 2 into I. Similarly, if it is a cube, I plus e whole cube. So a is approximated to e cube plus 3 into I square into e. So e is nothing but a minus I cube divided by 3 into I square. 3 into I square. Once you know the estimated values, then the logic will be extremely easy for you. Now, how to find out the cube root of 13? Cube root of 13 is greater than cube root of 8. So I want to cube the root of a. It is nothing but I plus e. E is nothing but a minus I cube divided by 3 into I square. Finish answer. I is nothing but cube the root of 8, it is 2. This is 13 minus 2 cube, it is 8 divided by 3 into 2 square. So answer for this question is 2 plus 13 minus 8 is 5. 4 3s are 12. Approximately 2 5 by 12, it is the answer. Approximately 2 5 by 12, this is the answer. Few more examples. Cube the root of 75, it is there. Cube the root of 75. Now, cube the root of 75 is greater than cube the root of 64. So, what will be the answer? It is 4 plus something. A is nothing but 75 minus 4 cube divided by 3 into 4 square. You will not find these in any of the regular textbook. 16 3s are 48. Answer is closer to 4 7 by 48. Answer is closer to 4 7 by 48. How to find the approximate value of a non-perfect square? How to find the approximate value of a non-perfect cube? Not a single doubt, you will get it in the class, and you don't need to remember anything. Only thing is that because it is approximated, e square and e cube, they are all smaller values. I forgot. For this, what all teachers will do, who just refer one book and take a class very nicely without giving you the proof. In case if you are taking a class for an IIT student or an NIT student, definitely he or she is not going to appreciate you if you just write the formula. I hope the idea, it is clear. Now we will generalize it. A is equivalent to I plus E whole square. E is nothing but A minus I square divided by 2 into I. If it is a cube, how to find the approximate value of a perfect cube? It is nothing but how it is derived also I discussed. A minus I cube divided by 3 into I square. How to find the approximate value for a non-perfect fourth power? If it is fourth power, E is approximately. If it is square, I got square. If it is cube, I got cube. If it is fourth power, I power 4. I power 4 derivative, it is nothing but I cube derivative is 3I square. It is nothing but 4I cube. 4I cube. From where you got? A is nothing but A power 4 plus 4I cube A. And so on. These are all smaller values. I hope it is clear. Now please make a note of one important concept. Approximate value of a non-perfect nth power. Approximate value of a non-perfect nth power. This is the heading for today's class. Once you know this concept, these are all extremely important concept. It is nothing but a minus I power n divided by n into I power n minus 1. This is nothing but E. E is nothing but an estimated increase. E is nothing but an estimated increase. Nth root of A. A is nothing but the non-perfect nth power. A is nothing but the non-perfect nth power. I is nothing but the integer just less than nth root of A. Just less than nth root of A. I hope the concept is clear to you. So there is no absolutely formula based learning. These are all mandatory concepts a student should know. Now, not only for a non-perfect square, non-perfect cubes, you can also derive it for a fifth power, fourth power, sixth power, seventh power. This is the beauty of thematic based learning. This is the beauty of thematic based learning. Once you learn the concept for the first time, then everything will be extremely easy for you. Thematic based learning. Any good doubt, any doubts that you got, you can mention it in the class. I hope the concept is very, very clear. In case if you enjoy these conceptual learning, kindly share this video with all your friends. We are starting a CAT batch. We are starting a CAT batch on 9th January. All the classes will be taken by me. 9th January. Asia's toughest examination. CAT batch, I am going to start the class. Today, 7th January, 7 p.m. The payment link will be activated. You can probably purchase. The actual course price is 20,999. For the first 500 or 300, I am not sure what is the upper cap. The fees is just 9,999. In case if you enjoy this content, click a like button and subscribe to Anil Nair Classes YouTube channel to know how to solve aptitude problems through a prism never seen before. Again, I will go back. This is what I firmly believe in. The class notes also will be available to you. The class notes also will be available to you. Free class, whatever classes I take, you can always WhatsApp this number. You can always WhatsApp this number to get these class PDFs. This is what I wish to teach. This is what is taught in the regular textbook. Thanks a lot. With love, Anil Nair.